Okay, so we've squared our block up, and the next portion of this project is going to be to cut the steps out on this. So we're talking about this step here and this step here. What we're going to do is we have a 750-inch dimension from here to here, and a 1-inch 125 dimension from the base to this side. And then also we have this 1-inch dimension over here and 1.5 inches in this direction. Notice the tolerances here on the heights are all plus or minus 5. The tolerances here on these lengths is plus or minus 15 that's shown down in the title block. So now we're ready to lay this part out. There's side A, C, and D. We've taken some Dykem and we've dyed the part up. When you use the Dykem, you want to put it on there as thin as possible. So our first measurement is 750. We're going to set our height gauge here at 750 thousandths. And we're going to scribe a line around the part. We're going to repeat that process for the 1-inch 125. And again for the 1-inch. And the 1.5 inches. Now we have this all laid out, and we're all ready to cut the part. So we have our part, and we've laid out lines at 1 inch, 1.5 inches, 750, 1-inch, 125. The first thing we're going to do is rough out this part. Now, when we do this, we want to end up down here at 0.760, and this is for roughing. At this point, we want this to come in here at 1 inch 135. Again, we're going to rough this out. This edge here, we want to make sure that we add some more onto this. So we're going to add another 10 thousandths to this. So this is going to be 1 inch 0.010, and this side here is going to end up 10 thousandths oversized, 1 inch 510. Now, when we go to chop this out, we're going to do it in segments because we don't really have the horsepower to cut this all out at once. First thing we're going to do is take a cut almost the width of the cutter, about 100 thousandths deep. So that's 0.100. We're going to take a second cut, about 100 thousandths deep, about the width of the cutter. And take another cut. Altogether, there's 5/8 of an inch that are going to come off of this. Another 100 thousandths. And then as we get down close to it, we're going to take these as smaller cuts until we get down to this surface altogether. Now, these are roughing cuts. So roughing cut means slower RPM, but heavy feed rates. So cut this out, and then once we get down to this 760, we're going to start walking the cutter in this direction. we're going to be taking conventional cuts across here. Now, this way, we could move in, 50 thousandths would probably be sufficient. You may be able to go to 100, but it takes a lot more manpower to power through that dimension. So we'll do that, and we're going to bring this in to 1 inch 510. So along the way, we're going to measure this till we've chopped this whole thing out. Then we're going to do the same thing at this surface. Come down 100 thousandths of the clip, bring this into the bottom, and then we're going to walk it across until we get to that 1 inch 100 or 1 inch 10 thousandths. Okay, so we're ready to start roughing this part out. I'm going to take a couple of parallels. I'm going to sit my part down in the vise. Now, you would think that you'd really want to mill this way, but I'm going to take it so that my datum C is against this back vise, and that's so that I can get in here easily to measure in this direction, as well as measure in this direction. Take the part. Everything's nice and clean, square, and everything's been trimmed. Make sure the parallels don't move. Make sure the vise is nice and tight. I'm roughing, so my speed is generally slower, but my feed's going to be a little faster, and I've adjusted for that. You need to do the math on that. We'll bring the machine over to the part. The end mill slightly above the part. I'm going to bring my end mill down to touch the workpiece. I'm also going to bring that end mill over to the edge, so that just hanging off the edge of that part. And now we're going to take the cut. Now I'm taking conventional mills. I want to make sure that my table is locked in the cross slide and it's locked in the up direction. I'm going to use the safety shield just because I don't like the chips going everywhere. I'm going to adjust this dial down to 0. I'm going to crank the table up 100 thousandths of an inch. Turn the spindle on. We're going to go this way real quick and make sure we're using the right feed rate. I'm going to turn this on and watch the cutter go. Now, you see how those chips are turning blue? That means that my RPM is too fast. So what I'm going to do is stop this. I'm going to put it into low gear. And we're going to slow this thing down. Actually, I'm going to speed it up. Feed rate is also going to have to decrease some. So let's do the math on that real quick. I just slowed my cutter down to 350. So 350 times 4 flutes times 0.007, I'm going for a 7 thousandths chip, gives me 9 inches per minute, 9.8 inches per minute. So we'll turn this on. Reset our feed rate. It's going to slow it down a little bit. We'll turn that cutter on. See it spinning backwards? If that cutter hits the workpiece spinning backwards, it destroys the cutter. Make sure it's going in the right direction. Now we'll take that cut. Through the workpiece, come back to our starting point. Take another 100 thousandths. 100 thousandths. And I can see that there's still a good, at least an eighth of an inch to come off this. Oh, there's more than an eighth of an inch to come off of this yet. But we're going down to 750, and right now we're measuring 950. We're measuring 973, and we're going to 750, so that means we have 200. Oh, we're going to 760, aren't we? So we're going to 760, which means that we have 200, about 210 thousandths to come off of this yet. This is just a roughing cut. And actually we're at 770 now. I really don't have to take that extra 10 thousandths off there, but let's go ahead and take it. Resist the impulse to take the cut across the bottom and the back side at the same time. What happens then is that end mill will actually deflect. So we want to resist on that. We're going to cut the bottom first and then the back side. Okay, so I'm at 754 right now, or 64 right now, 764. We're going to leave it there for finishing, and we're going to start working conventional milling against this back edge now to bring that into size. Now, what we're going to do here is we're going to take and we're looking at our Y direction. We're going to zero out our Y. And we're going to crank in 50 thousandths. And you can use a dial down here on the table as well. That works perfectly Here we're going to zero the Y out again, and we're going to measure that back side. And I see that I'm at 1 inch, 813 thousandths. We're going to 510. So we have 300 thousandths to come off of this yet. I've set my digital readout to 0. So we're just going to go ahead and walk this in, taking several cuts across here. But we're going to take 300 thousandths off of this. One inch 513. It's perfect. Perfect. Now we'll work on the next step. Incidentally, you just barely see a little line of blue between the scribe line and the edge of the part. And we'll back the table down. Now, we know that this is 1 inch 513 right now, and the next step is going to be 1 inch 10 thousandths. Again, it's oversized. So from here, we're just going to zero the Y out again. We're going to come in 500 thousandths. maybe a little less. Bring our table up. And leave our quill lock down. Turn the finger on. And bring this up till we just see it starting to touch the workpiece. Right there. And I'm going to crank off 100 thousandths. See the table is locked in the up position. Put my shield back up. We'll measure this again. I'm at 136 thousandths, 1 inch 136 thousandths, which is where I want to be. And in this direction we should be at 1 inch. We are at 1 inch and 15 thousandths. So we're really about 5 thousandths big, but we're going to leave it at that. We have roughed this part out now. The next step is to go on to the finishing cuts. Because my chips were changing color and there's some wear on my cutter, I'm going to change this cutter, put a better one in. I want to call your attention to these real fine stringy chips. We really shouldn't be picking them up with our fingers, but don't clean these up with a vacuum cleaner. They'll get stuck in the tube, so we have to make sure we use a dustpan and brush to pick up these chips. So now I've gone ahead and I got a new cutter. I put that in. I'm going to take a magic marker and I'm going to put a line on the front and the bottom of this part. I'm going to cut in the top slot first. I'm going to bring that step in first. And it doesn't matter if we do this step or this step first. It really doesn't matter which one we do. Bring the cutter over. Make sure that we're away from that back wall. I'm going to bring the cutter down so it just touches the workpiece. Now, I know that I've only got 10 thousandths to come off of this, so we're going to take the first cut and I'm going to bring it up 5 thousandths. I've changed my speed, I've changed my feed, and we're all ready to take this first cut. Now, remember, you want to cut the bottom first and then the back side. And we're looking for 1 inch 125. Well, I'm at 1 inch 123 right there, so I'm going to stop there. I'm going to work into this back edge. So I'm going to leave the cutter at the height that it's at. I'm going to turn the machine on. I'm going to bring it in until I just touch that back side. Now, I'm going to go back to the other side. I'm going to take the palm cut. I'm not going to, and this could be considered a string cut, but it's where I'm going to measure from. So I'm measuring 1 inch 100 or 1 inch 1,000ths right now. It's supposed to be 1 inch plus or minus 15. So I'm going to leave that there. We'll go back and we'll check this 1 inch 125 dimension one more time. It's still 1 inch 122. So that's in tolerance too. So now we can just do the math on this. So 1 inch 125 to 750 is 375 thousandths. So I can crank my table up 375 thousandths. I'm going to set the 0 on my table, crank up 100, 200, 300, 75. I know that my 1 inch dimension is here. I'm going to 1.5 here. So I know that on my digital it'll be 500 is where I'm going to finish up. But I don't want to finish against this back side, so I'm not going to take that cut just yet. It's measuring 748, which is perfectly fine. It's in tolerance. This should measure 1.5 inches. And it measures 1 inch, 500, right on the money. So the next step is we're going to deburr this and set it up to cut the slot.